welcome everybody to a coding ASMR video. What we're doing today is I'm gonna try out Tensorflow to code a neural network that will classify some images. And now the twist on this is that I have actually not prepared anything for this video. I only use Pytorch, so I know a bit of AI and neural networks and all that, but I have never used Tensorflow, so this is going to be exciting. Okay, so first I'm going to show you what I intend to accomplish here. Let's go to a search engine, in this case DuckDuckGo, and we'll search for MNIST classification. And now let's look at images. Now there's this image dataset called MNIST, and and it consists of all of these 32 by 32 pixels that have handwritten digits on them. And there are like hundreds, I don't know how many, but many of those images, and they have also saved which number it should be, which is very important for machine learning. And you can see this also here. You see that this is a 9, below that is a 2, and then there's a 7, which, I mean, is a very ugly 7, but let's not judge. Here's an 8, 0, and so on. So it's just the digits 0 to 9, and yeah, this is an open dataset that everyone can download and use, and it's a very beginner-friendly dataset that you can use for training a neural network. And yeah, on this image here we can see that we have always 32 by 32 pixels, and we want to train a network or a model in code which gets an image like this as input and then says which letter it is, so it can read letters. Now that's not the most intelligent thing, but like I said, it's a good intro model, and since I have never used Tensorflow before, this is the first thing I'm gonna try. Alright, for coding I'm gonna use Visual Studio Code. I'm gonna open this here, and this is our IDE where I will write the code. Now theoretically you can also write the code in your favorite editor or like anywhere you can write text, but using an IDE has some nice features that will help us along. But just so you know, Visual Studio Code, it's free, you can download it online. Nice program, very useful. Okay, so the first thing I will do is create a folder, actually. Now I'm here in my folder structure, I am in Documents, and I have created a folder MNIST Tensorflow in which we will work. And now I can open this folder in VS Code. And now it has opened this folder, Documents, MNIST Tensorflow, and yes, I trust the authors of these files because firstly, there are no files, and second of all, I will write all those files. Okay, so let's just create, this is horrible. Okay, let's create a new file here and let's call it test.py, and the pi stands for Python. And now it will activate our Python extension down here, and this is what I wanted it to do. Also, I want a new terminal, because the first thing you do, or I do at least, when I start a Python project, let's dismiss this one here, is create a virtual environment. And this makes sure that we have full control over all of the packages and libraries that we use in this project. Now, I always forget how to create a virtual environment, but let's see which Python version we have. It's also probably interesting for you guys. Let's see, Python -- version. Oh no, we have to write Python 3. That's different on Windows and Linux, so I always do it wrong. Okay, so for anyone interested, we have Python version 3.8.10. I think we already have Python 3.9 out, but I hope it's not going to be a problem that we're on 3.8. But we'll see. Okay. Now Python 3 -m venv, and we'll put it in this folder here. I hope that's how you write it. Did it work? I think it worked. There we go. Okay, now let's enter the path, find, and now we can say Python in this folder that we just created in this venv virtual environment folder, and then I select the Python interpreter. And now if I open another terminal tab, we can delete the old one. It automatically activates this virtual environment. And now this should be, yeah, Python is now version 3.8.10 in this virtual environment. You can see that we're in this because it says venv here. Okay, but enough about virtual environments. Let's install Tensorflow yet. I almost said Pytorch, but no. Today we're doing Tensorflow. And for that, we're gonna use the search engine. Just gonna type in Tensorflow and go to tensorflow.org. Now let's see here. An end-to-end open source machine learning platform. Tensorflow, the core open source library to help you develop and train machine learning models. Get started quickly by running Colab notebooks directly in your browser. See? I also could have done that, and then I wouldn't have to install it, but now we're trying to install it locally. Let's see. Get started with it. Is it going to open at Colab? No, okay. See tutorials. See the guide. I kind of want to install it. Okay, up here. Install. Right, it says Python 3.6 to 3.9, which is fine because we're using 3.8. It also says Ubuntu 16.04 or later. That's also fine because I'm using Ubuntu 20. And install Tensorflow with Python's pip package manager. Exactly. That's what we're trying to do. And here it tells us the command that we need to use to install it. And oh no, that's first requires the latest pip. Okay, let's just check. Copy. If we have the latest pip, I don't know. Paste and enter. Is it working? Okay. Oh, we had pip 20 and now we have pip version 21. That's fine. Okay. Now back to Tensorflow. It says installing is pretty simple. Current stable release for both CPU and GPU is just simply pip install Tensorflow. Alright, I can do that. Let's go back to our virtual environment. Pip install Tensorflow. collecting, and now it's gonna download, and you can see it correctly selected that we're on Linux, I think, and it needs to download 450 megabytes. So in the meantime, let me create a notebook file. MNIST, let's just call it MNIST, IPyNB. And this is the correct kernel, right? We also want this to be using the virtual environment that we just created. My whole laptop is super slow right now. I think I need to sit out this download. Alright, it has finished installing. It installed like a lot of things down here, and I just let it run. Okay, let's make this a bit smaller. I just don't like it if it's on my face. Okay, back to this notebook here. Notebooks, if you don't know notebooks, they're super useful for Python. So I can now write some code like 3 + 2, I know, most impressive code ever, and I can run it. And yeah, please install this. Thank you. Right, okay. Now it has also installed the functionality for the notebook. Let's try running the simple code again. And now it's starting the kernel for the first time, so it takes a while longer. And now you can see it executed the code and it shows me the output right after. And I can have another code down here, another cell, and write something different like print hello world, and execute this with Control Enter, and it will also show me the output. But it will also remember everything I did up here. So if I define a variable up here, I can use it down here. Incredibly useful. Okay, now we have installed Tensorflow. Let's go back to the website. We have installed everything. And now it wants us to deploy the model. No, I don't want to deploy the model. I want to learn. Introduction. Yes, please. Learn the foundation of Tensorflow with tutorials for beginners and experts. Yes. Learn more, please. Okay. Tensorflow is an end-to-end open source platform for machine learning. See the tutorials. Beginner quick start. That is always very useful. Does it tell me how to get MNIST dataset though? This short introduction uses Keras to build a neural network that classifies images, train this neural network, and finally evaluate the accuracy of the model. Okay, so first, oh yeah, there we go, they do it on MNIST. Dark code theme. Oh, if you could have the whole page in dark mode, that would be very helpful too, but okay. So the first thing we're gonna do is import TensorFlow STF. Right. Can I split my screen? Let's put this here and put our notebook on the right. Okay, so I'll remove our 3 + 2 and say import TensorFlow STF. Run this, and it takes a while. Okay, now we load the MNIST dataset by writing MNIST. We do tensorflow.keras.datasets.mnist. Oh, you can see it also suggests me to use the fashion MNIST, so this is also available right with TensorFlow. Okay, let's execute that. And then they also want us to do xtrain and ytrain. So xtrain will be the images and ytrain will be the labels. So it will tell us if it's supposed to be a 4 or a 2 or whatever on this image. And then we also get a test dataset. And we just get all of these by calling the MNIST variable that we have just saved and saying load data. Okay. And this gives us our training images and then also the testing images on which we can evaluate the model to see how it does on images that it has not trained on, so unknown images. And in the next step, now I guess this means the images are like normal images where the values of the pixels will be between 0 and 255. And for our neural network, we want them to be not bigger than 1, let's say. Ideally, you would want your values to be between -1 and 1, and they should be 0 centered, but in this example they're going for between 0 and 1. Let's just do what they say and not think too much about this. Okay, let's execute this. And now it's downloading the data from some Google server because TensorFlow is a library developed by Google. And it already finished. Okay, yeah, I can work with that. I guess it's only a small part of the MNIST dataset, or it will download the rest of it later. We'll see. Okay, now we built the neural network, and for that we used the sequential API, which is pretty similar to Pytorch. Okay, so the model will be tensorflow.keras.models.sequential, and the first thing will be a flattened layer. So the image, let's see if I can show you one of the images. Let's look at xtrain shape. Okay, so here we can see that we have 60,000 images in this variable, and they are each 28 by 28 pixels. I think I said this incorrectly earlier. I said they were 32 by 32 pixels. They are not. Now we can know that they are 28 by 28 pixels, but doesn't make a lot of difference anyways. Okay, so we have the 60,000 images. Can I see the first one, please? Maybe. And let's see the shape of that. Now let's pip install matplotlib. Okay, now I've installed an additional library to plot some things, and we need to import this in import matplotlib.pyplot_splt. And now execute this again. Okay, and now let's see, plt.imshow. Let's save this first image in this variable. And now let's try and show it. Yep, there you go. That's one of the 60,000 images in the X training set. And it's black and white, but by default Python shows a black and white image as this purple and yellow thing. I think if we do cmap and then gray, it should, yeah, that's what it originally looks like. Right, so that's the image, and you could see up here that if we just look at the values, I accidentally took a screenshot. If we just look at the values up here, then you see that they have just zeros and ones in them. First a lot of zeros, and then it skips some, and then it just shows us the last row, and that's because the first pixel rows are all black, so they're all 0. But I promise you there are some ones and some values in between 0 and 1 in there too. So this is this huge matrix that is 28 by 28 values. And yeah, for a neural network, we want it to be just a long list of values. We don't want it to be a matrix. So the first thing we do is we flatten it. And apparently we do input shape 28 by 28. So I guess we need to tell the layer what the input will be. So that's the first thing. And this is kind of new. We don't have this flattened thing in Pytorch as far as I know. And then we can do pretty much whatever we want. This is a neural network after all. I'm just gonna follow the tutorial for now. We do a dense layer, and that's the same as a fully connected layer, or in Pytorch it's called a linear layer, and these are just different names for the same thing. And we tell it how many units we want. So if we see the input will be of the dimension 784, and now the next layer will have 128 units, I'm guessing. And we can also directly tell it that we want the activation to be a ReLU function. That's also quite fun. In Pytorch we define that separately. Okay, the next thing is already a bit more advanced, and that is we're using a dropout layer. And that means we're setting some of the outputs of the layer, of the previous layer, this dense layer here, to 0 during training. And the 0.2 says that we will set a random 20% of the neurons to 0. And that will introduce a bit of noise into training and make it so the network doesn't have the chance to just learn all the images by heart, because every time it sees the same image, for example this 5, it will look slightly different to the model, because there will be some black spots. Kind of. You can kind of imagine it as if there were some black spots around the image that are trying to confuse the model, and that will make sure that the model tries extra hard to learn, so we expect better performance from that. And then we do the second and already last layer, which is again a dense or a linear layer. And here the output needs to be 10 because there are 10 different classes. So either we have a digit that's 0 or 1 or 2 or 3 or 4 or 5, you know, all the way up to 9. So 10 different possibilities, and we need an output neuron for each of those. So yeah, this has to be 10 because of the number of classes. And the 128 and the 0.2, you can kind of choose them however you like and do whatever works. Okay, let's execute this. What is it complaining about? Yes, I don't have a GPU. This is a laptop. Is this a problem? I don't know. We will see. Looks like it's just warnings. Oh, they're kind of annoying though. Okay, now the tutorial says, for each example, the model returns a vector of logits or log odd scores, one for each class. Yeah, that's what I was talking about, the output right then. Now, let's see. Now we're getting the predictions for the first image. Okay, now we're doing model of the first image. Let's just see what it does without the NumPy. Aha. It does not like me. Oh, I know why. Okay, let's do it the way they did it. So the way I did it, I get see the shape. I get 28 by 28, but the model always expects a list of images. Even if we only put in one image, it wants it to be a list with only one image in it. So the way they wrote it is xtrain and then only select the first one, but this will give us a list back. See, if I do shape on this, it will be 128 by 28. So we need this to put into the model. Right, go back down, not too far, and do it the way they wrote it as well. Okay, now, okay, this is interesting. This gives us a Tensorflow tensor of the shape 110. Oh, this is useful that it tells you this. And then it tells me that the NumPy array, which is saved in this tensor, is this. So you can see it has a negative value for the first one. So it's basically saying it's probably not a 0. Now these are all negative. 0, 1, 2, 3, 4. So this is positive, so maybe it's a 4. 5, 6, so this is the largest so far, and yeah, it's the largest overall. So our network, which we have not trained at all, it's a very unexperienced network so far, would say that this number, which is clearly a 5 as we have seen up there, is a 6, because it's just guessing at this point. Okay, now we can also write NumPy, and that will convert it to a NumPy array. So this will just give us the entries instead of all the other information, but I kind of like the other information. Okay, and now we save this in predictions. Execute this again. Okay, and then the next step is to use the Tensorflow NN softmax function that converts these logits, so the outputs that we got, to probabilities for each class. let's do that. Tensorflow NN softmax predictions. Execute this again. And here we can still see that the biggest one is this one that is equivalent to a 6. But now they are all positive, so now you can think of them as probabilities. Now you can see that with probability 14.45, the network thinks this is a 6. And they also want us to convert this to NumPy. Okay. Yeah. Right. They also give you this note here. It is possible to bake this softmax in as the activation function for the last layer of the network. While this can make the model output more directly interpretable, this approach is discouraged as it's impossible to provide an exact and numerically stable loss calculation for all models when using a softmax output. Is very interesting. Okay, I'm used to it outside the network anyways. Okay, now the losses, sparse categorical cross entropy loss. Wow, that's a mouthful. Takes a vector of logits and a true index and returns a scalar loss for each example. What does that look like? From logits equals true. Okay. A bit lost here. Let's save this as the loss function. Tensorflow keras losses sparse categorical cross entropy, and then we want to say from logits equals true, right? Yes. This loss is equal to the negative log probability of the true class. It is 0 if the model is sure of the correct class. This untrained model gives probabilities close to random. Like I said, it just guesses. 1/10 for each class, so the initial loss should be close to minus Tensorflow math log of 1/10, which is approximately 2.3. Okay, and then it wants us to try that. I can do that. Now we calculate the loss function, and as a first argument it wants to have the true labels. So y train, the first value, and the predictions that we saved earlier. Yeah, in our case it's 2.54, so it's different than in their case because they are always randomly initialized. And yeah, but it's like roughly 2.3, and it would be closer to 2.3 if we took the average of more than one image. Okay, now we're doing this model compile thing. Let's see here. So we do model. Can't tell you what this does. It does something to a model, but we've chosen an optimizer and we have saved the loss function, and we also said that we want the accuracy metric. Okay, and now we have this magic function, the model.fit method, which adjusts the model parameters to minimize the loss. This model fit, and we give it the training data set. So X and Y train. And we say for now we want 5 epochs. I have no idea how long my PC will take for that. Let's just run that. It's complaining that it takes too much memory. Yeah, my laptop is quite at its limit with all the recording going on. Now it has looked at the first epoch, so it has looked at all the training images, all 60,000 of them, and it has already gotten an accuracy of 91%. So in 9 out of 10 cases it knows which digit is on an image, and after the second epoch it's at 95%, and here in the third epoch we can see it's like at 96, 97%. So this is already pretty perfect, but we'll see how high we get with this. But we have to remember it's only on the training images, so it is currently looking at the same images over and over again. What I'm wondering is how many images it uses at once. Did it automatically try how high the batch size can be? I never told it how high the batch size is, so I don't know what it's doing. We're still at 97%, so I guess that's pretty much the best we can do with this model. And it's very close to done now. Okay. It's still doing something up here, even though the model says it's finished. I don't know what it's doing, guys. Let's see. Oh, now it finished. Okay. Oh, it gives me a callback history. Okay. Now we can also evaluate to see how it does on the test set, so on the images that it hasn't seen. Let's get a new code cell and say model evaluate X test, Y test. Also, let's see what verbose does. Oh, that was fast. How big is the test set? X test shape. It's 10,000 images, so training was 60,000 and this is 10,000. Okay. Let's close this again. So even on the test data set, which it hasn't seen before, the accuracy is still 97%. That is pretty good. The tutorial tells us the image classifier is now trained to about 98% accuracy on this dataset. To learn more, read the Tensorflow tutorials. I thought we did that, but I guess there's more. If you want your model to return a probability, you can wrap the trained model and attach the softmax to it. Ooh. Okay, so then we would define a new sequential model and use our previous model and also a softmax layer. And we call this the probability model. I'm not going to do that. That seems weird. I never do that. but it's an interesting thought. I like this. Okay, and that was the whole tutorial. I would like to see an image where it did the wrong thing, but I think we'll keep this for another day. So this brings us to the end of this video. I have reached my goal of training a TensorFlow model on the MNIST dataset, and if you have any ideas or challenges for me to try with TensorFlow as a beginner, then let me know, and otherwise I'll see you next time with either another coding tutorial or coding follow along, or maybe a bit more math content again. We'll see. Alright, bye, see you next time.